Okay, welcome back. We're starting chapter 23, and in this video we're looking at chapter 23A only, discrete random variables. So first of all, what is a random variable? It means that we're dealing with a variable where we have a random situation. We're not going to be biased at all. So if we're tossing a coin, then we're not using a biased coin. And if we're tossing dice, we don't have a biased dice. Okay, so we're being random. Discrete random variables or continuous random variables. So if you recall, a long time ago back in statistics, we talked about discrete data and continuous data, and this is also related to this, okay? So something that we count, okay, is discrete, okay? And things that we measure are continuous. So discrete means the counting numbers, so 0, 1, 2, 3, 4, etc. And measuring means we can have decimals and fractions. They do not have to be just the counting numbers. It can be a measurement between 5 and 10 centimeters, for instance, and a measurement within that 5 to 10 centimeters could be 8.93, for instance. Okay, so measuring, continuous data, counting, discrete data. So discrete random variables has to do with counting things as well. All right, so probability distributions. Really important to know what that means, and I'll give you an example here. We're tossing two coins. We're defining the random variable x as being the number of heads. Okay, so the number of heads. Now, we could draw this situation. So here I've drawn a 2D grid of this situation. Coin 1 could be heads or tails, and coin 2 could be heads or tails. And everywhere where a grid mark meets is a possible outcome. So if you remember that in terminology from Chapter 22, probability. So possible outcome. Here we have 4 possible outcomes, and I've color-coded them because the blue one represents a tail and a tail. Another way of saying this with regards to probability distributions is the probability that x is equal to 0. So what does this mean? We defined x in the question as the random variable x being represented by the number of heads. Okay, so number of heads 0. That means both coins were tails. The probability of that happening is 1 out of 4 because it happens at one possible outcome out of 4 possible outcomes. Okay, probability that we have a tail and a head or a head and a tail. Now, in the case of probability distributions, order does not matter, okay, because x is representing the number of things that we're looking for. So here we're looking for x to be 1. In other words, we're having one head, and there's 2 possible places out of 4 that can happen. So the probability that x is equal to 1 is 2 to 4, or 1/2. Okay, and likewise, probability of getting a head and a head. That means the random variable x is equal to 2. So the probability of the random variable x being equal to 2 is 1 out of 4. Okay, now, important to remember, 2 basic things. We know this from recall. Each probability must be between 0 and 1. Okay, anything in between there as well, any decimal number in between there. If we're talking about percentages, then 0% and 100%. All the probabilities added up together have to equal 1. Okay, so this is an important definition of probability distributions. Okay, both of these definitions apply. Now we could write this probability distribution, we could represent it in a table like this. We have x and the probability that the big random variable x is equal to that little x. The possibilities were either 0, 1, or 2. So 0 heads, 1 head, or 2 heads. Okay. And the probability of having 0 was 1 out of 4. Probability of 1 was 1/2. Probability of 2 was 1 out of 4. Now, is this a probability distribution? Let's check it. Does it follow the two rules? Is every probability between 0 and 1? Yes, check. Do all the probabilities add up to 1? A quarter plus a half plus a quarter equals 1? Yes. So yes, this situation is a probability distribution. Okay. If you have not yet downloaded the document for 23A, or if you're not able to do that, if you're not using a printer, then go to the textbook questions. We're looking at textbook question exercise 23A, number 1. Let's talk about whether these things are discrete random variables or continuous random variables. So classify them. The first one, the quantity of fat in a sausage. Well, that's something we would have to measure, so that would be a continuous random variable. B, the mark out of 50 for a geography test. Well, that's something we would count up those marks. Okay, so that would be discrete. C, the weight of a 17-year-old student. Okay, so that's something we're measuring. It's not only just whole numbers. Okay, it would be continuous numbers. Okay, so that would be continuous. D, the volume of water in a cup of coffee. Again, we're measuring that, so that's continuous. Whereas E, the number of trout in a lake, we would count those, so that would be discrete. Okay, so you can finish those and finish the questions from 23A. And I will make the next video about example 1 from page 609. Have fun.